Alright, we are going to take a look at this problem. It's a great problem because we have to know a decent amount about exponential functions, and we also have to know a decent amount about what a domain is in order to solve it. So what it really wants us to do is to compare how two graphs look. It gives us f of x here, an equation for it, and it gives us g of x here, another equation. Now, I went ahead and made some tables because this is how we'll do it. We'll just pick points for x, see what it gives us for f of x, or y, we could call that as well. We know that our function notation always just means the y value. And then we'll do the same thing for our second equation. And we'll get two graphs, and we'll be able to compare them and answer the questions that it asks. All right, so let's get started on that. So our first equation, f of x. Let's go ahead and just, a good one to start with, I love to start with 0 for x. So that means, so f of 0 is equal to, sorry, that's supposed to be equal to, negative 5 times 4 to the 0 power. Because we just plug a 0 in where x was. We know anything to the 0 power is 1, so negative 5 times 1 is negative 5. Now let's plug 0 in here for g of x. And we get that g of 0 is equal to negative 4 times 5 to the 0 power. We're just putting a 0 in where the x is. And we know anything to the 0 power is 1, so g of 0 is negative 4 times 1, which will just leave us negative 4. Okay, I'll do a couple more here with you, and then we'll graph them. Let's say when x is 1, what do we get? Well, that means f of 1, f of 1 is equal to negative 5 times 4 to the first power. Anything to the first power is just itself. So this is equal to negative 5 times 4, which is equal to negative 20. So when x is 1, we get a negative 20 for f of x, or our y value is negative 20. Now let's go ahead and do the same thing for g of x. G of 1 is going to equal negative 4 times 5 to the first power, which is also going to give us negative 20, isn't it? Negative 4 times 5 to the first is like 5, negative 4 times 5, which is equal to negative 20. 1, negative 20. So it looks like they're going to share a point at 1 comma negative 20. Okay, now I'm going to pause and calculate a few more values, and then we'll graph them together, now that you have the hang of it. So it would be cool if you've paused as well and tried plugging in maybe negative 1 for x, or 2 in for x, some other values, and then we can fill out our chart a little more. But instead of wasting time on solving those together, I'll just fill in some values for us here. Alright, now we've got our chart filled out a little more, so let's go ahead and plot these points. So f of x over here, when x is 0, we have y is negative 1, 2, 3, 4, 5. So there's a big fat point right there. When x is 1, we have y is, or f of x is negative 20. So that's going to be way down below. We can see that it's going to be getting further than this picture even goes. And when x is 2, we're going to go down even further than that. So it's going to drop really, really fast. Okay, we can't really draw those 2 points, but we know that this graph, as x gets bigger, it goes down really, really, really fast. So let's see, when x is -1, so there's a -1, our y is -5/4, which is just a little bit more than 1.2. So we have a point about there. When x is -2, we have -5/16, which is just about a third. So when x is -2, we're going to have a point about there. Now we know the shape of exponential functions. They look always something like this. They go either up or down, or they could go the other direction, up, or the other direction, down. And they go steeper and steeper and steeper. It looks like this graph, if we were to keep picking points, so if x got smaller and smaller and smaller, we're going to get closer and closer to 0 in the y values, but we'll never touch it if we were to keep graphing a bunch of points. So that means that I can draw a picture that looks something like this. And it goes down very steeply there. Whoops, I missed my point. So this is the picture that I'm going to get for my f of x. Now let's look for g of x and see what we come up with. I think it will be something similar. So when x is 0, we go down 4, 2, 3, 4. When x is 1, we go down 20, which is going to be too far down again to draw on our graph. So it looks like it's going to be the same direction. And when we go over 2, we go down even further, 100, which was too far down to fit on our graph. But let's look here. When x is -1, we have y is -4/5, which is just shy of 1 itself. A point about there. When x is -2, we're going to go down even less. So it'll be a point like that. So this graph will look very similar, except it approaches 0 faster than the other. Okay, now that we kind of have a picture of these two graphs, they do look very similar, don't they? You can see that this one crosses the x-axis at a different point than this one does. This crosses at -1, 2, 3, 4, 5. And this crosses at -1, 2, 3, 4. So there's a difference. But besides that, just looking at them, they look very similar. Let's read the questions now. It says, use your graph to determine which of the following statements are true. G of x equals f of x for all values in the domain. The domain, remember, are just x values. So for any x value we pick, see we picked all of these, it says that f of x and g of x are going to be the same. Well, let's see if that's true. When we chose 0 for x, we got different answers. So already we know that's a lie. In fact, the only one where we pick the same x and get the same y is this second one here, because we have 1, -20 and a 1, -20 here. But it looks like to me all of these other ones are different. When I pick 2 for x here, I get a different value for y. 2 for x here, -100 compared to -80. So this one we know can't be correct. The next question is, it says that g of x, our second graph, is bigger than f of x for every value in the domain, for any x value. So let's see. Is g of x always bigger? When I chose 0 here, yes, it's true, g of x is bigger. How about down here though, when I choose 2 for x? I get a -80, and then here g of x is -100. That's 20 smaller than -80. So that means this one can't be right, because g of x is not always bigger than f of x. Okay, let's see. G of x is bigger than f of x for all values greater than 0 in the domain, and for values less than 0, g of x is equal to f of x. That's not true because of the same reason here. For all values greater than 0 in the domain, well, 2 is greater than 0. And remember, f of x is bigger in this case. So that's not correct either. Which leaves us, hopefully, this final answer is right. It says g of x is less than f of x for all values in the domain. Well, is that true? That's not true either. So this problem, my friends, does not have a good answer. Let's come up with our own that works. We know that we could say, let's see here. Based on our table here, past this point when x is equal to 1, it looks like for every value that we pick after that, f of x is going to be smaller than g of x. I'm sorry, f of x will be bigger than g of x as soon as we get bigger than 1. So something we could say is that f of x is greater than g of x when x is bigger than 1. So we have to select our own answer here because none of these were true. Thanks for watching.